Okay, so you're seeing a transfer from the elastic potential energy store to the kinetic store here. From the elastic potential energy store to the kinetic store. So you could use this to fire something. Right, what we've got here is a transfer from the kinetic store here to basically light energy, which can't be stored. It's an energy transfer as light. So it's kinetic energy store in terms of the moving hand and the moving cogs, and then we've got the light energy as a transfer at the end. It's actually going via the electrical pathway here. So we've got energy at the start in terms of kinetic energy. Now we've got another one here where the hand is supplying gravitational potential energy, and in terms of where the energy ends up, we can see the energy ending up here in the kinetic store, and it'll stay in this kinetic store for a little while, but we can also see that it's moving up to the gravitational potential energy store as well. When it's at the top of its swing, it's got more gravitational potential energy, and that's transferring back and forth from gravitational potential to kinetic, to gravitational potential to kinetic. Now here we've got energy stored in the candle itself in the form of a chemical energy store. So we've got the chemical energy store, chemical store, transferring to the thermal store here in terms of the candle being hot, and also some energy being transferred to light as well. And remember that light can't be stored. Okay, this is a fun one. We've got energy being stored in the spring in the elastic potential energy store, and then it's transferring very quickly to the kinetic store. It's going up in the air, and when it's up in the air, it's got more gravitational potential energy. Right, this one, we've seen the batteries fall out. They're a store of chemical energy. They're not a store of electrical energy. They store chemical energy. So you can't store energy using the electrical pathway. Now when this is running, we've got that chemical store being transferred ultimately to the kinetic store. So just a reminder, these store chemical energy, they don't store electricity. You can't store electrical energy. Right, this is a fun one. What we've got here is we've got some masses balanced up on a platform here. They've got gravitational potential energy. Now we can use this pulley to transfer the energy to kinetic energy and drive the trolley. So gravitational potential energy store here. And the moving trolley's got kinetic energy. So we're transferring from the gravitational potential energy store. That gravitational energy store is basically, it's decreasing. And when it decreases, the kinetic energy store increases. And now increasing the gravitational energy store again. So gravitational to kinetic here. Gravitational energy store decreases, the kinetic store increases. Another example of the same thing here. Car at the top of the ramp has got an increased store of gravitational potential energy, and that's transferring to kinetic energy as it's rolling down the ramp. So gravitational potential energy to kinetic energy. Now this one, we've got the elastic potential energy store transferring to the kinetic energy store, and then it's up in the air, so it's got more gravitational potential energy, and that's transferring back to the kinetic store, and then back to the elastic store, and then back to the kinetic store, and then back to the elastic store, then back to the gravitational potential energy store. Right, this is Newton's cradle. It can show lots of things, but we're starting off with a supply of gravitational potential energy. It's being transferred to kinetic energy. That kinetic energy is being transferred from one of the balls to the other balls. and then that's going to transfer back to the gravitational potential energy store. Now, this is supposed to keep going for a really long time to show that actually energy is not created and it's not destroyed. So in theory, this should be able to go for ages, just transferring kinetic energy back to gravitational potential energy, back to kinetic energy, and so on. In reality, it makes quite a lot of noise. So some energy is transferred to sound energy. The balls will also warm up a little bit, and it will generally warm up the surroundings.